See, now we were talking about the physical states of any matter, right? We know at this
Yeah.
point there are three states of matter. One is solid, then you have
Solid.
liquid, right?
Mhm.
And you have gas, right?
Yes.
Now, if I'm talking about solid, I can take an example of, we'll take example of water, right? In case of solid, it will be called as ice, right?
Yeah.
And when I'm talking about liquid, it is simple, the liquid form of water, right?
Water.
And gas is there, so we are going to talk about the water vapors, right? Or we can
Mm-hmm.
say steam, right? Okay. Now,
Yeah.
just imagine ice in your mind and talk about its shape.
So it's a cube.
Yeah, it's a kind of cube, or we can say it is a fixed shape.
Fixed shape. Yeah, it is a
Fixed
fixed
shape,
shape.
right? If I have like I have a ice tray in which the cubes are like being formed. So if I put those
Mhm.
cubes in a glass, the cubes will remain cubes only before they melt,
Yeah.
right? So
Yeah.
I've got a fixed shape.
Yeah.
Right? Now, just imagine you are having water in your water bottle, right? Water bottle
Mm-hmm.
is cylindrical, right? Now, just imagine pouring that water into a glass. Glass is
Mm.
small in size, so the shape got changed.
Yeah.
Yeah.
Of the water. Yeah.
Yeah. So there is no fixed shape in that.
No fixed shape. Yeah.
Yeah. When we talk about the liquid water, there is no fixed shape. And
Fixed
when
shape.
we're
Yeah.
talking about the water vapors or steam, so definitely it has no fixed shape, right?
Yeah.
Doesn't have any fixed shape.
No fixed shape either. Yeah.
Now comes the volume part. Now, okay, the word volume, what picture you have in your mind when I'm talking about volume?
I think of like a size of something.
That's pretty good. You're very close to. Volume is basically what we say ki the space occupied by any substance. That's its volume.
Space
Okay.
occupied by any
So if
substance. Okay.
if I'm saying the solid, so it'll have a
Mm.
fixed volume,
Mm.
right? It'll have fixed volume.
A fixed volume.
Yeah, definite volume, or
Okay.
we can say like you can use the word definite. And when
Mm.
liquids are there,
Mm.
liquids, see, if you have 500 ml of water in your bottle,
Yeah.
pour that water in a glass, 500 will come now, right?
Yeah.
Will not increase to 600. No, it cannot,
Yeah.
right? So it will be
You know,
definite volume, right? In liquids
definite
also, the
volume as
volume
well.
will be definite, fixed. But in case of vapors, is it so it'll remain the same? No, because
No, I think it'll distribute into the air.
it is ever expanding, actually. It takes up the
Mm.
shape of the container in which you are going to put that. So here
Yeah.
is the variable volume.
Variable volume. Okay.
Yeah, we're not having any definite volume, but yes, volume will be varying.
Hmm.
Okay. Next, can we compress that ice cube? No, it is difficult.
No.
No, it is
Yeah.
so compression or reducing in size with pressure,
Hmm.
right?
Hmm.
Compression is difficult in case of solids, right?
Hmm.
Same is with liquids. Here also, compression is very difficult. You cannot,
Hmm.
right? But in case of vapors, because vapors, they have got very huge space in between, they are easily compressed. I'll give you a
Hmm.
um, model kind of thing. Just I'm drawing the thing so that we can have a clear picture of what is happening actually. Um,
Yeah.
okay, just a second. Mm, okay, I hope my screen is there. Yeah,
Yeah, it's there.
yeah,
I can
because
see it.
something else opened, so I was like, I'm not that techie na. So, so sometimes you're
That's
stuck.
fine.
See, I'm making a kind of solid. In
Solid, yeah.
you have particles in any substance, okay?
Hmm.
And when we are talking about the solids now, the particles are very close to one another.
Hmm.
They're very, very close to one another. When we are talking about the liquids, particles are
Yeah.
close, but they are not that close. Okay, they are
Yeah.
close, but a little
They
farther
come, yeah.
as compared to
Yeah, a
the.
little far.
But when we are talking about the gaseous state, the particles are too far away.
They're just everywhere.
Yeah, it is like They have got so much of space. Now, why I'm drawing this thing? So that you're able to understand the basic concept behind the solid, liquid, and gas. Okay.
Yeah.
The particles are too close to each other, so
Hmm.
they are going to attract the other molecules with a very strong force of attraction. Okay.
Hmm.
So they have got the maximum force of attraction,
Maximum force of attraction.
right? Now, you can see the particles are very close to one another. So there is minimum interparticular direction, or we can say
Hmm.
space, right? There is distance is too less, right? So there
Hmm.
is minimum intermolecular space.
Hmm.
So that is the reason, na, because there is very less space and the force of
Hmm.
attraction is too high. So we are not able to compress them because space is not there, right?
Yeah.
See, for example, if I have a classroom and I can make 20 students sit, right? And
Yeah.
all the 20 are present. So how can I accommodate five more? I cannot.
You can't. Yeah.
Yeah, I cannot. Would I make the students sit on the floor? No, I cannot. I have to make them sit on benches now. So that is the reason
Yeah.
we are not able to compress. But when we are talking about the liquids now, although space is a little more, okay, it is in between the solid and gaseous, but still because
Yeah.
of the force of attraction, you are not able to compress them.
Compress them. Okay.
We are not able to.
Because the force is like just spread apart.
The force of attraction is there. It is, it is having at the distance in which the particles are there. They are at their own position. And you would believe one thing more, these particles, na, they keep on oscillating, being at their position. They're always oscillating like this, right?
Yeah.
And when we are talking about the gaseous state, we have so much of space. So there is like least force of attraction,
Yeah. The
maximum
least.
distance. So it can be compressed easily,
Yeah.
right? There is less force involved and the distance is too high. So we can do that, right?
Yeah.
So that's the reason why gases, they are like very compressible. Now, what happens
Yeah.
when I'm going to apply heat to a solid?
Yeah.
Now, see, all the energies which are there with every particle, every molecule, that is termed as the sum total, is termed as the internal energy of that substance.
Mm-hmm.
Like, for example, if I have 100 molecules now, so energy,
Yeah.
100 molecules will be added up to get the sum total of this energy. And that will be called
Mm.
as your internal energy. Okay.
Internal and.
Now I am heating. Got it? I am providing heat. And
Mm.
heat is a form of energy.
Yeah.
Yeah,
And yeah.
right. Now, a substance, I'm sorry, had already some energy. Externally, I'm providing more energy,
Yeah. Okay.
right?
So extra. Yeah.
There is an add-on in the total energy amount. So what
Yeah.
happens? What happens? See, I'm taking a portion of the solid. Now, these particles were very close to each other, but now they are
Yeah.
having added on energy with them. So what they are going to do? They are going to oscillate more frequently and with a higher amplitude, right?
Okay.
Okay. A little
Yeah.
picture like, and now when they are moving with higher amplitude, they are going to push away the particle,
Push away the particles. Okay.
thereby
Because they
creating
don't
some,
they don't have enough space. Yeah.
ah, yes, they're creating some space, thereby leading to the another state of matter, which is liquid.
Oh, okay.
Okay.
So solid is there and then they have extra energy coming in. So
Ji.
they push it away and the result of pushing away is liquid?
Yeah, it's liquid. Actually, it is creating the it is increasing the intermolecular distance.
Okay.
Right now, by
Inter-
oscillating in a large amplitude, they are actually increasing that distance. And increased distance as compared to solid is your liquid state. And this
Yeah.
process is known as melting.
Melting. Okay.
Yeah. And in chemistry language, we call it to be as fusion.
Fusion. So melting is fusion.
Yeah.
Okay.
Okay. Perfect.
got it.
You understood the concept of melting, what is actually happening inside the ice.
Yeah, so it's oscillating.
Yeah, I'll write it down. They are actually
Yeah.
oscillating with larger amplitude. With
Hmm.
larger,
What's amplitude again?
I'll let you know.
Sorry.
I'll let you know. See,
Yeah.
um, I'll make it over here. Suppose this is a support and a bob is hanging. Okay, just
Yeah.
imagine your wall clock.
Yeah.
Yeah. Okay. Then when it is pushed to one side, the maximum
Yeah.
distance it is covering to one side, that is called
Yeah.
your amplitude.
So the distance maybe?
Yeah, it is called the lateral displacement.
Okay.
Okay? Like, for example, if this is like a bob and I'm going to oscillate, right? It was in the center,
Yeah.
then it went like this. So this distance is known as your amplitude. And if it
Amplitude. Okay.
increases, so naturally it is going to push away the adjacent molecules.
Hmm.
Right? Got it now? Clear?
Got it. Got it. Yeah. Now I got it.
Okay. So if I keep on continuing with the supply of heat, okay? If I am continuing with the heat supply, that means now the liquid molecules, they'll have more energy,
Yeah. They have extra add-on to.
extra added on energy. So now again, they are going to oscillate with much larger amplitude,
Yeah.
right? Thereby creating
Right.
more space in between the particles.
More space. Yeah.
Yeah.
Because so if they oscillate,
Yes,
then they
with
kind of
more
yeah.
larger amplitudes, thereby leading to evaporation, or I can say boiling. Not evaporation, we'll write down boiling. Evaporation, we'll understand later on. Okay, it is boiling.
Boiling.
And your vapor form is formed,
Hmm. Vapor?
right? Vapor
Yeah.
form, gaseous form. Now, these two
Yeah.
steps are clear. Is it clear? Should I move on?
Yeah.
Yeah.
Yeah. You can.
For example, up now, what happens? I was supplying the heat energy. Now, I am in
Hmm.
no to supply energy. Now, I want to relax. Now,
Yeah.
procedure will be reversed. For example,
Yeah.
if in case of vapors, right,
Yeah.
I'm going to back out my energy. I have taken away the source of energy. What will happen? What
They
is
will compress back together, maybe?
the larger oscillations will be reduced to the lesser one. Very good. The energy
The
is,
oscillation.
yeah. Now there is no added on energy, na? So how can they oscillate?
Yeah.
Got it? So now they are going
Yeah.
to undergo condensation,
Condensation. Okay.
right?
Hmm. Could you explain the word condensation?
Yeah, sure. It is basically the change of gaseous state into liquid state. For example, if you are taking,
Okay, yeah.
got it? If you're taking a cold water in a glass, steel glass, you will find
Yeah.
liquid water outside the glass,
Yeah. Yeah.
right? So how, from where did it came? It came from atmosphere actually. The temperature got
Yeah.
reduced on the glass surface and the air which was in contact with the glass surface, here we just took away the energy. So now
Yeah.
it cannot move with a larger amplitude. Hence, it is converted into liquid. Got
Liquid. Okay.
now,
Got it.
if I'm talking about the liquid, then again the energy has been taken away. Now the
Hmm.
amplitude will be further reduced. And
Okay. Further.
this is going to
So it'll be
decrease
very
further.
high.
Yes. So now they are going to freeze. This is how water,
Free.
yes, it freezes to form ice. And we, for
Yeah.
freezing purpose, we keep them in your refrigerators, right? Where temperature
Yeah.
is lesser, right? Now, condensation is also known as liquefaction. Liquefaction,
Liquid. Yeah.
right?
Hmm.
And when I'm talking about the freezing, freezing is called as solidification.
Solidification. So liquefaction.
Yeah.
Liquefaction.
Yeah. So melting, boiling, condensation, freezing. These are all
Yeah.
changes of state,
Hmm.
right? Got it?
Changes of state.
Now,
Okay.
in some solids, now what happens? There is a change in state, but they just skip the liquid part.
Hmm.
For example, when we are talking about ice, what happens? When you take out ice out from the refrigerator and keep it on the like gas, right, gas stove. So what happens? First it will melt, it will turn into liquid, and then it will start boiling, right? But some substances are there which are going to skip the liquid state, which means they are going to, change from solid directly into gas.
Hmm.
Okay, I'll let you know a very practical example of that. Naphthalene balls.
Sorry, what?
Naphthalene balls. The white colored balls are there, na? We keep it in our
Yeah, yeah, yeah.
winter clothing in beds, if you remember. If I
Yeah,
don't know
yeah,
you
yeah,
keep
yeah.
or not, but yes, we keep. But see, if these naphthalene balls would have changed into liquid, the clothing would have been
Yeah,
damaged. And our mothers will
yeah,
be like, oh shit, what is happening? Right? So we took
yeah.
advantage of that. See, now my solid, which is your naphthalene ball, right? Naphthalene. You got the picture, na? Naphthalene balls, the white colored small balls, which are sometimes kept in
Yeah,
wash basin also. I
yeah.
don't think so. You're getting the picture of naphthalene balls at this moment.
I'll just like quickly Google it to see like, what they
Right. So they are
look like.
changing from solid to gaseous state. Now, this
Yeah,
change is known as sublimation,
yeah.
right? These are sublim.
Yeah, I got
You got the thing. Okay.
yeah, I got
That's pretty. Okay. Okay, so this saved our clothing from being damaged and we're utilizing the property. And the reverse can be also done. Like the gaseous state can be directly changed into solid state. And that is also very useful for keeping the
yeah.
things in your without getting, wet. For example,
Hmm.
carbon dioxide. Carbon dioxide,
Carbon dioxide.
right? When it is converted into solid, it is called dry ice. The
Dry
things
ice.
are,
Okay.
yes, things are kept cooler, but without getting wet.
Hmm.
So dry ice is basically your solid carbon dioxide.
Solid CO2. Okay.
And this process from gaseous to solid state is known as deposition.
Deposition. So from solid to gas.
Yes. No,
Gas.
gas to solid.
Gas to solid. Yeah.
Yeah, it is gas
Okay.
to
Gas.
solid. That's called deposition. But if you are going from solid to gas, it's called sublimation. And you can write down
Okay.
the examples of sublimation. There are naphthalene balls, then you have camphor, um iodine, ammonium
Hmm.
chloride. These are some examples which undergo sublimation. Matlab, the
Hmm.
solids, they are going to get converted into gaseous state directly, right?
Yeah.
Yeah. So let's see what we have further. Okay, so that was the thing. So solutions and suspensions we are going to do in the next class. But you are going to do one thing. You're going to select one element and one compound
Mhm.
and one mixture. And you're going to compare their properties. Just make
Okay.
a flow chart of that, right? Any solid, liquid, and gas also. So
Yeah.
that all the properties are learned by you, right?
Yeah. Okay.
Otherwise, फिर we'll forget, na? So फिर that won't help us, right?